In this video, we're going to take a look at exam revision for the binomial expansion. So if you haven't already, do check out the previous videos that we covered for this topic, such as Pascal's triangle, the binomial expansion, binomial estimation, and so on. So if you have done that already, let's take a look now at some exam style questions. Starting off with question 1 here, then we have a nice straightforward question to get us started. We're given that 30 choose 12 is equal to 30 factorial over 12 factorial times b factorial, and we have to write down the value of b. So for this question, you need to understand how this n choose r formula actually works. If I write down the formula here, n choose r, then this is equal to n factorial over r factorial times n minus r factorial. Okay, so you can see how that applies to this one here. It's 30 factorial over 12 factorial, and then we just need to figure out b here, where in this case, b is going to be equal to 30 minus 12. So 30 minus 12, which in this case will give us 18 there for b. And there we have it, so that's our solution for the very first question. Like I said, nice and straightforward, would only get us 1 mark, but just a nice introduction there for this video. Moving on to question 2 here, where we're asked to expand 1 minus 3x to the power of 9 in ascending powers of x up to and including the term in x cubed. So to begin with here, what I'm going to do is I'm going to write down the result for the binomial expansion. You can get this from the formula book, but if you don't have that to hand, this is what you should get. So for a plus b to the power of n, what I'm going to get here is a to the power of n plus n choose 1. We times it by a to the n minus 1, so the power of a reduces by 1 each time. I'm going to get b here, so the power of b will also increase by 1 each time. So I'd then get n choose 2, times it by a to the n minus 2, and then times that by b squared, and so on. Okay, and this will keep going up to b to the power of n. Okay, so that's our binomial expansion. I just need to apply that now for our expansion here of 1 minus 3x. So 1 minus 3x to the power of 9 here. So to begin with, a to the power of n, that would give me 1 to the power of 9. So I'm then going to get n choose 1, which would be 9 choose 1. So we get 9 choose 1 times a to the n minus 1, so that's 1 to the power of 8. And then we times it by b, where in this case, b will be minus 3x. Okay, so we times that by minus 3x. We then do n choose 2, so that would be 9 choose 2. Times it by a to the n minus 2, so that's going to be 1 to the 7. And then b squared here, that would be minus 3x all squared. Minus 3x all squared. Now I need to do this one more time here because we need the term in x cubed here. This is just the term in x squared. So just doing this one more time here, I'm going to get 9 choose 3. So 9 choose 3. And then times that by 1 to the power of 6. So 1 to the power of 6. And then finally minus 3x all cubed. So minus 3x all cubed here. So what I need to do now is simplify as we go. Well, 1 to the power of 9, that would just simply be 1. I've then got 9 choose 1, which is 9, times it by 1 to the 8, which is 1. Well, 1 to the 8 is 1, times it by 9 would give me 9, then times it by minus 3x, that would give me minus 27x. So minus 27x there. So what have I got now? So I've got 9 choose 2, which would give me 36, times it by 1 to the 7, which would just give me 36 still, and then times it by minus 3x all squared. So what I've got here is 36 times positive here. This will become positive. So 9x squared, which in that case will give me 324x squared. So plus 324x squared. And then finally, we've got 9 choose 3 here, which is 84. So I get 84. Now I times that by 1 to the 6, which is just, well, 1 to the 6 is 1 times by 84, would just give me 84 still. And then minus 3x all cubed, that would be minus 27x cubed. Minus 27x cubed. So put this into your calculator here, and what you should get is minus 2,268x cubed there. Okay, and there we have it. So each coefficient there is in its simplest form. We don't have to do anything further, and that's our solution there to part A. Now for part B, it says using a suitable substitution for x and your expansion from A, obtain an estimate for 0.97 to the power of 9, giving your estimate to 3 decimal places. So remember, when we're using binomial estimation like this, What I need to do here is take this into two parts. So I've got my expansion here of 1 minus 3x to the power of 9. But then we've also got this estimate here for 0.97 to the power of 9. Okay, we've got 0.97 to the power of 9. So ignore the powers for now. What I want to do here is consider what the value of x must be, so that 1 minus 3x is equal to 0.97. Okay, so this base is equal to this base here. To do this then, I'm going to add 3x to both sides and subtract 0.97 off both sides here. So in that case then, I'm going to get 3x here is equal to 0.03. Okay, which in that case would give us x equals 0.01. Okay, just dividing both sides by 3. So my substitution here will be x equals 0.01. Okay, so sub x equals 0.01 into our expansion here from a. Okay, so into a here. So in that case then, what I'm going to say then is 0.97 to the power of 9 is approximately, so like I said, just substituting that into this expansion here. So I'm going to get 1 minus 27 lots of 0.01 plus 324 lots of 0.01 squared. So 324 lots of 0.01 squared. And then finally, we're going to run out of room a little bit if I just do it underneath here. In fact, let me just rewrite that. So let's try again. We just do it underneath with a bit more room. So we've got enough room to do it all in one. So 0.97 to the power of 9 is approximately 1 minus 27 lots of 0.01. I've then got 324 lots of 0.01 squared, 324 lots of 0.01 squared, and then finally minus 2,268 lots of 0.01 cubed. Okay, now here you just need to put all of this into your calculator here. So what you should get here is 1 minus 27 lots of 0.01, that would give me minus 0.27. Okay, I've then got 324 lots of 0.01 all squared. So again, just put this into your calculator, and what you should get here is 0.0, so 0.0324, oops, 324, and then finally minus 2,268 lots of 0.01 all cubed here. That will give me minus 0.002268 there. Okay. So again, just put all this now into your calculator here, simplify this, and what you should get then for 0.97 to the power of 9 is 0.760132. Okay, now we want to give this to 3 decimal places, so in that case then, we would get 0.760 there. Okay, so that's to 3 decimal places, and that gives us a solution to that question. Moving on to question 3 here, where we're asked to find the coefficient of x to the power of 4 in the binomial expansion of 2 minus 3x to the power of 7. So all we need to do here is find the coefficient of x to the power of 4. We don't need to do the full expansion. If you don't know how to find the general term, then you would need to do the full expansion. However, we can save a lot of time by just using the result for the general term. So for the general term here, let's just write this result down. Then this is equal to n choose r, so n choose r. We then times it by a to the n minus r, a to the n minus r, and then we times it by b to the power of r. Okay. So in that case, then if I want the coefficient of x to the power of 4, my n here is 7. So if we just write everything down, n is 7. R here will be 4. That's the power that we need. So r is 4. A is 2. And b is minus 3x. Okay. So b is minus 3x. So if we apply that to our result here then for the general term, I'm then going to get 7 choose 4, n choose r. So for the coefficient here, so for the coefficient of x to the power of 4, this is equal to 7 choose 4. We then times that by a to the power of n minus r. So a here is 2, so that's 2 to the power of 7 minus 4, giving me 3 there, so 2 cubed. And then we times this here by b, which is minus 3x, and then we do that to the power of r. So minus 3x to the power of r, which is 4. Okay. So I just need to evaluate everything here separately. So 7 choose 4 is 35. 2 cubed is 8. And then minus 3x to the power of 4, this would be positive. I'm going to get 81x to the power of 4 there. Okay. Now clearly we only need the coefficient here. I'm not too bothered about the actual x to the 4. But clearly all I need to do here then is 35 times 8 times 81, which in this case will give me 22,680 there. Okay. So that's x to the 4. So the coefficient then is 22,680. So coefficient is equal to 22,680 there, giving us a solution to that question. Taking a look at question 4, now we're asked to find the binomial expansion of x plus 1 over x to the power of 5, where x cannot be equal to 0. So how do we do this here? Well, again, we're just using the binomial expansion. So if we start off here, I'm going to get a to the power of m. So a here is x. So I'm going to get x to the power of 5. So x plus 1 over x to the power of 5. And to begin with here, we get x to the power of 5. Okay, so that's my first term. For my next term then, we're going to do 5 choose 1. So we get 5 choose 1. The power of x here will reduce by 1. So we times that now by x to the power of 4. And what I'm going to do here is I'm going to use this dot here to represent multiplication because we've got x's involved. I'll just use a dot to represent multiplication. And then we times that by b here, which is 1 over x. Okay, so times that by 1 over x. Okay, so that would be my next term. Now, like you can see, I'm going to quickly run out of room here, and we've got to keep going all the way up to x to the power of 5, or b to the power of 5, which in this case will be 1 over x to the power of 5. But we'll get to that at the very end. So now my next term here will be 5 choose 2. So we've got 5 choose 2. We now times that by x to the power of 3, so this reduces by 1. So x to the power of 3. And then we times it by 1 over x to the power of 2, 1 over x squared. My next term here then will be 5 choose 3. We should have just about enough room here. So 5 choose 3. And then times it by x squared, so x to the power of 2. And then I times this by 1 over x to the power of 3. So going down onto the next line here, I've then got 5 choose 4. So 5 choose 4. I then times it by x here, x to the power of 1. Times it by x. And then I times it by 1 over x to the power of 4. And then finally we arrive at the very last term here, which will, like we just said, will simply be 1 over x to the power of 5. Okay, so we times it by 1 over x to the power of 5. That's our b to the power of n there. Okay, so it looks pretty messy to start with here, but let's simplify each term here as we go. So to begin with, I've got x to the power of 5. I can't do anything with that. It is just simply x to the power of 5. So we'll leave that at the beginning. I've got x to the power of 5 there. I then got 5 choose 1, which is 5. I then times it by x to the power of 4. And then I times it by 1 over x. So if we just simplify this a little bit here, x to the power of 4 times by 1 over x. So x to the power of 4 times by 1 over x is the same as x to the power of 4 over x, giving me x cubed there. Okay, so what I'm going to get then is 5x cubed for my next term. So plus 5x cubed. Okay, for my next term then, so what I'll do is I'll cross off or tick off in a different colour each part as we go. So we've done x to the 5, that's done. We've done this part here. So we're now on 5 choose 2. So go back to our original pen colour. So 5 choose 2. That would give me 10 here. I'm going to get 10 times x cubed times 1 over x squared. So x cubed over x squared. So x cubed over x squared. That would just simply give me x there. Okay, so I'm just simply going to get plus 10x. So plus 10x there. Again, let's just highlight that in a different colour just to indicate which part we've done. That's that part. Nearly there now. So 5 choose 3. Again, that would just simply give me 5 here, sorry. In fact, no, sorry, it'll give me 10 5 choose 3. So 5 choose 3. Let's try again. That's 10. Okay. So 5 choose 3 is 10. I then got x squared times 1 over x cubed. So 1 over x cubed is 1 over x cubed. So what I'm going to get then is x squared over x cubed, which will leave me with 1 over x. Okay, I've got 10 times 1 over x, giving me 10 over x. Okay, so plus 10 over x. So let's highlight that again, just so we don't get confused, because it's very easy to get confused, like you've already seen. I have made that mistake. So now we've got 5 choose 4, which in this case is 5, which is what I was reading. So that's 5, and then times it by x, that would be 5x, and then that's over x to the power of 4 here. So I've got 5x over x to the power of 4. That'll cancel, that will reduce to the power of 3, so I get 5 over x cubed there. So 5 over x cubed. And then finally, so that's this part done here, and then I've got 1 over x to the power of 5, which in this case will simply give me 1 over x to the power of 5. Okay, so 1 over x to the power of 5 there. And there we have it. So that's each term simplified or in its simplest form, and that gives the solution to that question. Moving on to this question here now, where we're given that 1 plus 4x to the power of 6 is equivalent to a plus bx plus cx squared. Now we're asked to find the integer values of a, b, and c. So what we simply need to do here is just use our binomial expansion. So to begin with here, we're going to get a to the power of n. So if you need to here, just identify a, b, and n. So a here, little a, will be 1. B here will be positive 4x, so it'll just be 4x. And n here will be this power of 6. Okay. So applying that to our binomial expansion, I'm going to get a to the power of n. So I'm going to get 1 to the power of 6 here to start with. So I get 1 to the power of 6. So I'll just write this down here. 1 plus 4x to the power of 6. That's going to be equal to 1 to the power of 6. We then get 6 choose 1. So 6 choose 1. And I times it by 1 to the power of 5. And we reduce this power by 1 each time. So 1 to the power of 5. And then we times it by b here, which is 4x. Okay. Times that by 4x. Now we only need to go up to x squared here. So on the next term, we are actually done with this question once we've simplified. So I'm then going to get 6 choose 2. So 6 choose 2. And then times it by 1 to the power of 4, reduce this power by 1. And then we've got 4x here to the power of 2, and this power increases by 1 each time. So we times it by 4x to the power of 2 there, 4x squared. So that's the only term we need to go up to here. That's our last term, cx squared. So all I need to do now is simplify each term here. Well, 1 to the power of 6, we can't do anything with that. It is just simply 1. So I get 1 there. I've then got 6 choose 1, which is 6. Times it by 1 to the 5, so that's 6 times 1, giving me 6. And then times that by 4x, that would give me 24x. We get 24x there. And then finally here, we've got 6 choose 2. So 6 choose 2 is 15. Times it by 1 to the 4. So that's 15 times 1, which would give me 15. Then we times it by 4x squared. So that's going to be 16x squared. So I've got 15 times 16x squared, which in this case would give me 240x squared there. Okay, so plus 240x squared. And there we have it. So all I need to do now is just identify the integer values of a, b, and c. So in that case then, a is just our constant at the beginning, so that's 1. B here is going to be the coefficient of x, which is 24. And c then to finish with here is going to be the coefficient of x squared. So that would be 240 there. Okay. And there we have it. So that's our solution to that question. And finally, to finish with here, let's take a look at the very last question. So what we've been given is this function f of x, which is equal to 2 plus kx to the power of 10. Now we're given that k is a positive constant, and the coefficient of x squared in the binomial expansion of f of x is 1280. We're asked to find the value of k. So the first thing that I notice here is the coefficient of x squared in this binomial expansion of f of x is 1280. So what that means is then we can use the result here for the general term. So we just write that result down again. So for the general result, the binomial expansion for a given coefficient here, this is equal to n choose r. We then times it by a to the power of n minus r, so a to the power of n minus r, and then we times it by b to the power of r. Okay. So to begin with here, let's just recall the values in this example of a, b, n, and r. So a here, that would be 2. B here, well, that will be this kx, so that's going to be kx. N in that case, this would be my power, my function here, f of x, that's going to be 10. So n is 10, and r in this case is the power of the coefficient that we want. That would be x squared in this case, or sorry, the power of 2 here, so r is equal to 2. So that's everything that we need. So what I'm going to do now is just plug that into my general result here and see what happens. Okay, so I'm going to get 10 choose 2, so I'm going to get 10 choose 2. We then times it by a to the n minus r. So that's going to be times by 2, because a is 2, to the power of n minus r. So 10 minus 2, giving me 8 there for my power. And then we times it by b to the power of r. So b here is kx. So we times that by kx to the power of r, which is 2. So kx all squared. Okay. So let's just simplify this for now. Okay. So 10 choose 2, that will give me 45. I'm going to get 45 here. We times it by 2 to the power of 8, which is 256. So times by 256. And then we times it by kx all squared. So that's going to be k squared x squared. Okay, so times by k squared x squared. Okay. So in total then what I'm going to get here is 11,520 k squared x squared. Okay. And what we're told here at the beginning of this question is that k is a positive constant. So that's important. We'll highlight that for now. And we're also told the coefficient of x squared in the binomial expansion of f of x is 1,280. So all I need to do now is match these coefficients here. So I've got 11,520 k squared. That's my coefficient of x squared here. But we know that that's equal to 1,280. So therefore what I can say then is 11,520 k squared is equal to 1,280 there. Okay. That's what we're saying here. And all I need to do here now is solve for k, okay? So I'm going to divide both sides by the coefficient of k squared here. So k squared is equal to 1,280 divided by 11,520. And this simplifies quite nicely here. I get 1 over 9, okay? So this is equal to 1 over 9. Now, what you might be seeing straight away here is I'm going to get two solutions, because when I square root this in a moment, so we've got that k squared is equal to 1 over 9. So clearly when I square root this here, I'm going to get two solutions. I'm going to get positive 1 over 3. I'm also going to get minus 1 over 3. But it's important here that we're told that k is a positive constant. So in other words, k is greater than 0. So in that case, then we can omit the negative solution here, and we only take the positive solution. So therefore, k is equal to 1 over 3 there. Okay, taking the square root of both sides here, I'd get k, and I'd get 1 over 3 there. Okay. And there we have it. So that's our solution to that question, and that brings us to the end of this video on exam revision for the binomial expansion. In the next video, we're going to take a look at solving triangle problems.